Hey class, we're going to do part 2 on special right triangles here. We're going to start out with some calculator buttons. So a couple things to note when you're putting in trig functions into your calculators. If you are given degrees, remember to make sure that your calculator is in degree mode, so degrees should be highlighted. Different calculators look different, so make sure you know how yours works. Now, for most calculators, they only have the 3 main trig functions, sine, cosine, and tangent. So if you want to find the cosine of 37 degrees, you just type it in cosine of 37 degrees, which is 0.7986. We're going to go to 4 decimal places. However, you'll notice my calculator does not have a secant button. Some calculators do, the majority do not. So what we have to remember with secant is that it is the reciprocal, that secant of an angle is defined to be 1 over cosine of that angle. And so if you want to find the secant of an angle, and that's not a right triangle, you have to type it in as 1 divided by cosine of that angle. And so if you do 1 divided by cosine of 54, oops, that was not right. 1 divided by cosine of 54, that will give you the correct value for the secant of that angle. Now notice that when we did the cosine of an angle, it is less than 1. We got 0.7986. That makes sense because remember, you find cosine by taking the adjacent side over the hypotenuse of a triangle. And then secant is above 1 because that is the hypotenuse over adjacent. And the hypotenuse is always the biggest side of a triangle. And so the cosine of an angle should always be less than 1 because the adjacent side is always smaller than the hypotenuse. And the secant should always be more than 1 because you're going to have the bigger side on top. So it's something to keep in mind when you're plugging them into your calculator to double check if they're correct. So if you want tangent of 12 degrees, you can use your tangent button. But if you want cotangent, so 0.2126. But if you want cotangent, you have to do 1 divided by tangent of that angle. So 1 divided by tangent of 72 would be 0.3249. So go ahead and practice those. Get familiar with your calculator so you know where those buttons are. The next thing we're going to talk about in this unit is the special right triangles. And special right triangles include 2. We have the 45-45-90 triangle, which is the isosceles triangle. So since the angles are congruent, the sides opposite the angles are congruent. And the ratio for this triangle is 1 square root of 2, which means that the side lengths are the same and the hypotenuse is square root of square root of 2 times as big. So in a standard 1 square root of 2, or it could be 2 square roots of 2, or it could be 5 square roots of 2. So the hypotenuse is always square root as 2 times as big as the legs, and the legs are always equal. So we'll see how that works. You have a nice equation here you can use too. And then we have the 30-60-90 triangle. Now the 30-60-90 triangle has a 30-degree angle, which is the smallest angle. The smallest angle is across from the shortest side because the angles and side lengths are related. And then we have a 60-degree angle, and that's going to be across from the longer side. And then the 90-degree angle is the biggest angle across from the longest side, which is the hypotenuse. Now this has a ratio of 1 square roots of 3, 2, which means that the short leg and the hypotenuse is 2 times as big as the short leg. So hypotenuse is twice the value of the short leg. And then the long leg is the square root of 3 times as big as the short leg. So if you have a short leg as x, then you would take 2 times x to find the hypotenuse, and then you would take that x value times the square root of 3 to find the long leg. All right, let's do a few examples. So this is our 45, 45, 90 triangle. I'm given a side length, which is 5. Since the angles are the same, the sides are congruent. And the ratio is 1, 1, square roots of 2, which means that if this is 5, 5, this would be 5 square roots of 2 for the hypotenuse to keep that ratio the same. In the 30, 60, 90 triangle example here, I'm given the hypotenuse. The hypotenuse is the longest side. The ratio is 1 square root of 3, 2. If your longest side is your 2, that means your shortest side is half of that. So you could also remember it as x square roots of 3, and 2x. So your shortest side is going to be half of your hypotenuse, so 6. And then your long side is going to be the square root of 3 times as big as the short side, or 6 square roots of 3, so that the ratio is proportional. It's all 6 times as big. So the values I was looking for here was the short side and the long side. Okay, to do a couple more of these, we have a 45, 45, 90. It's kind of tipped a funny way, but this is my hypotenuse. So these sides are congruent. So this would also be 9 square roots of 2. And your ratio is 1, 1 square roots of 2, which means if your side length is 9 square roots of 2, then this side is also 9 square roots of 2. Then your hypotenuse is going to be 9 square roots of 2 times another square root of 2, because the hypotenuse is always square root of 2 times as big. If it's like a 1.414, so 1.4 times as big as the leg. And then to multiply this, you'd get 9 times the square root of 4, which is 9 times 2. So your hypotenuse is going to be 18 there. This one is similar to our last example with the 30, 60, 90. The 8 is across from the right angle, so that is our hypotenuse. It's 1 square root of 3, 2 for this one. And it goes in order because square root of 3 is like 1.8. So 1.7, so it's 1.72. So the two legs are just, it goes to the biggest. So the hypotenuse is double your short leg. So if the hypotenuse is 8, the short leg is 4. And then the long leg across from the 60 is the square root of 3 times as big as the short leg, or 1.7 times as big. So we leave that as 4 square roots of 3, 4 times the square root of 3. All right, we're going to do it a few more times. So if you have solving a triangle, remember that's finding all of your missing side lengths. If you have a 30-degree angle, we know that the other angle has to be 60 because it has to add up to 180, and 30 and 60 make 90, and plus another 90 is 180. And then since it's a special right triangle, we want to find our exact answers. So instead of using trig, we're going to use our special right triangle ratios. One thing I notice is that we are given the long leg here. So my ratio for this triangle is 1 square root of 3, 2. And remember that goes in order 30, 60, 90 from smallest to biggest, 1, 1.7, 2. And you're given 7 as the side across from the 60 degrees. So if you add some x's in here, like if this is 1x, and this would be x times the square root of 3, this would be 2 times x. So your ratio would be x square roots of 3, and 2x. That means that your long leg here of 7 is your x times square root of 3. So your short leg times the square root of 3 gave you 7. So to find your short leg, you have to work backwards. So since the short leg times the square root of 3 equals 7, you would take 7 divided by the square root of 3 to find that value and go backwards. So that means that your short leg would be 7 over the square root of 3. That could give you a decimal answer. As an exact answer, you're going to want to rationalize that. So you're going to leave it as 7 square roots of 3 over 3. So that's going to be your short leg, which is our A value. And then, so this is 7 square roots of 3 over 3. And then our hypotenuse is going to be double that. Oops, over 3. And so your hypotenuse is going to be 7 square roots of 3 over 3 times 2 because it's double. And remember, you take a fraction times a whole number, the whole number only applies to the top. So 7 times 7 square roots of 3 times 2 would be 14 square roots of 3 all over 2, which is going to simplify to just 7 square roots of 3. So there is our right triangle solved. So that one was a little bit tricky because you were given the long side and you had to work backwards to find the short side, which means you had to divide by the square root of 3 instead of times by the square root of 3. And then one more here using special right triangles. We have a ship that travels 53 miles per hour northeast on a course that forms a 30-degree angle with the positive x-axis. Okay, so the ship is traveling positive x-axis, 30-degree angle, so it's traveling north, never eat soggy waffles. It's traveling northeast, a 30-degree angle. It is traveling 53 miles per hour for 2 hours. And so if it's traveling 53 miles, 53 miles per hour, how far is it going in 2 hours? You would have to multiply these together. So 53 times 2, it's going to go a total of 106 miles in 2 hours. That's going to be this distance right here, 106 miles. That's the value, or that's the course of this ship. Then it's asking you to find how far east and how far north. Typo there, but how far east and how far north. So this would drop it down into a right triangle. This is our north distance, and then this would be our east distance. And it's a 30, 60, 90 triangle, and we're given the hypotenuse. So we can solve this using our ratios. We have a ratio of 30, 60, 90 is 1 square root of 3, 2. Our 90-degree side is 106, which means that half of that would be 53, and that would be our north distance, because that is across from our 30-degree angle. And then we'd have 53 times the square root of 3 would be our east distance, because that's across from our 60-degree angle. So that'd be our exact answer. If we wanted to approximate that, it would be 53 square roots of 3, or approximately 91.8 miles. So we could answer this question by saying that it traveled 91.8 miles east and 53 miles north. And that is it for special right triangles. It does take some practice to get this down, so keep practicing. Thanks for watching.